Hello everyone, welcome back to the channel. Today we are going to understand application load balancer. Basically, what is this application load balancer? So in AWS basically provides something called as elastic load balancer, and there are four types of elastic load balancers that you can use. One is obviously application load balancer, which we'll cover today. This is the theory part. The hands-on part will be in the different video. So application load balancer, which actually operates at layer 7, and the other load balancer is network load balancer, which operates at layer 4, and it is for TCP and the UDP protocols. And then we have the gateway load balancer, which is basically for your firewall intrusion and data inspection, etc., that you can use. And the fourth one is the classic load balancer, which is the legacy classic load balancer. It is just for the legacy support. It was the previous generation load balancer which AWS used to provide. So AWS doesn't encourage using classic load balancer. It says use application load balancer or network load balancer in that case. So with this, now we'll start what is application load balancer. So first of all, what is a load balancer, right? Let's understand that concept. Say suppose I have multiple instances here. Instance 1, instance 2, instance 3, instance 4, right? And say my client wants to connect to these multiple instances. Just try to understand this, right? We have 3 or 4 instances and my client wants to connect to those instances. Right? Connecting to those instances, it means the client has to remember or know the IP addresses of those instances. Correct? That is one part. Now, suppose if for some reason the IP address of my instance changes, then again client needs to be updated. Otherwise, if client sends the request with the old IP address, obviously it will not hit the instance because that IP address has changed. So those kind of issues we face with the if we are not having load balancer. That is one part. So what load balancer does it provides a single DNS, or you could say DNS URL, using which the client just only knows the DNS URL of application load balancer. It does not worry about how many instances or which all instances are serving the client. So that's the advantage here. So there is clear segregation, or you could say encapsulation, that happens at the top of EC2 instances. Now that is one part. The other part is load balancing, right? Say if I have 4 instances and if there is no load balancer, right, then how do we distribute the traffic? Say all the clients are sending request to only one instance. The 3 instances are sitting idle. So who is going to do that distribution of load? So this application load balancer, if we keep application load balancer in between, then you don't have to worry about it. Application load balancer by itself will actually do this distribution of load. So it will decide, okay, it will check, okay, this instance is actually processing so many requests. Now this instance is idle. I'll send this request to this particular instance. So that's the advantage of application load balancer, or basically any kind of load balancer. Load balancer is smart enough to know which instances are free to handle the request. And now coming to the application load balancer in AWS, right? So first of all, it operates at layer 7. It supports HTTP, HTTPS traffic. It supports WebSocket. It supports gRPC. So just keep this in mind. It supports only layer 7. And when we say layer 7, basically it can process your request header. It can process your URL. So it can know which client has sent what client information, basically, that you might get through header. So it can process that header and it can transform it, and then you can use it. The other instances can use it. Basically, you can forward all those information. It can read that client information very easily because it is operating at layer 7, and then it can send to the EC2 instances or any servers, and those servers can actually use that for their own manipulation and processing. So that's the thing of the layer 7 that we spoke about. Now, how ALB works, right? So we need to understand that part. So client sends the request to ALB. Okay, now this ALB, first it will go to the listener. It will go to one of the listener based on your protocol and your port number. It will be hitting one of the listener of that application load balancer. Load balancer can have multiple listeners, okay, and it will hit one of the listeners. And inside those listeners, there will be different types of rules. So the rules could be like it might be doing host-based mapping routing, sorry, host-based routing. It could be path-based routing. It could be header-based routing. It could be method-based routing. It could be query string-based routing. So there are a lot of options which ALB provides. So when I say host-based, it means this one api.example.com. So this is host-based routing. So here the host is api.example.com. So it decides, okay, say I have api.example.com, then I may have api.demo.com, api.demo.com. That would be a different host. So in this way, it can segregate based on the rules that you have set. Then we have path based. Path based is basically slash admin star slash image star. So this is path based. Okay, this is path based, and it will hit based on the rule that you have set. It will hit one of the target groups. And then the request is forwarded to the selected group that we have spoken about. So just keep that in mind. What ALB will do is it will identify which target group the request should go to. And target group is again set up just before the ALB's provision. You can do that first. I would say the first step would be to create the target groups that you want to do, and then based on the target groups, you create the rules. I'll show it in the AWS console also. And then there is one more thing that ALB does is it performs the health checks of this target group. Basically, it will check, okay, if this is healthy or not. If it is healthy, then it will basically show this, basically call that particular target group. So the advantage of ALB is again the health checks. So it will keep checking whether the target group is healthy or not. If it is not healthy, then it will not send a request to that particular target group. So that's the advantage. And as I was explaining, we have different types of routing types. So path based again slash user slash order slash payments, etc. Okay. So these are the various types of routings. Then we have host based routing. So these are basically rules. The rules in the listeners, inside listeners, there will be rules. So inside rules, you can create these different kind of rules. If I want path based routing, say like I want slash users. If it is slash users, call user service. Slash orders, call order service. If it is host based, then that api.company.com, API service admin.company.com. Here basically URL is changing. Here your domain is changing basically in this case in the host based routing, right? And in case of path based routing, you are changing the URL. And header based routing, you can send all the information in the header also, like I told you, because it is operating at layer 7. It can read the headers. If because it can read the headers, it can manipulate the header. It can basically read the header, it can understand the header, and then it can process the header based. So here it is going to process that, okay, if it is user type equal to premium, then call the premium sub. Again, because it can read it, the headers and everything. So now it can identify if it's a get post service or a post service. So I may segregate the write service and the read service, right? So that is why it is forwarded as method based routing. Query string again. So if it is type equals to book or type equals to movie, you can specify any type of query string. And then based on your query string, again, you can divide. So these services would be set up in the target group. Just keep that in mind. And what ALB will do is it will forward it to the target group. Now, another important thing that ALB provides, okay, is the SSL and TLS termination. Say suppose when client is connecting to ALB, so what ALB will do is it will say client, okay, connect to me using HTTPS. Okay, so client will basically connect to the ALB using HTTPS using the valid certificate, and then client will connect to ALB. Now, what ALB can do is it can terminate this SSL connection here itself, okay, and then decrypt it, and then it can call the target, basically the instances or the web servers which are behind the load balancer. Now, the interaction between ALB and the instances, it is in HTTP. So this is called as SSL termination. So ALB is smart enough to actually do that. You don't need to have your SSL uh, encryption to be continued or required at the after the load balancer. So that's the advantage you get. So you are reducing the SSL overhead on time. So that this is one part. In many organizations, it is not allowed. Even the internal communication between services, it is in HTTPS. But in case it is allowed you are actually able to do the SSL termination. Then the health checks. We spoke about the health checks. So ALB checks the health of the targets in the target group. So there are target groups, right? So ALB is going to check the health. You configure the protocol, you set the path of the health, could be actuator health, could be slash health, whatever API that you have written for health check, and then it will check and then it will set okay. So ALB knows that yeah, I'm getting 200 okay response. The target group is up and running. It is fine. The other part is authentication. You can also do authentication at the ALB layer itself. If suppose client is trying to access my application via the load balancer, what I can do is I can set up my user base or basically whatever authentication methodology that I have used, right? So I can integrate at the load balancer level itself. So if the user is not a proper user, right? It is unintended user, then basically ALB will check here itself and throw it out. It will not even hit the application. That's the advantage that we get. So it can authenticate users. Once it is authenticated, only then it will send to the application. Then we have options of sticky sessions. See, when one client is connecting to the target group, you have multiple instances inside the target group, correct? So now, say suppose client one is connected to instance one, and there is some processing which is happening, right? So I might want that my next request also should go to this instance one only. So this is called a session affinity, or you could say sticky sessions. So you can enable this sticky session at the ALB level itself. What ALB will do is it will insert a cookie and then it will send it to the client. So when client sends next time the same cookie, then it knows that okay, I need to forward to the instance one only. So this is session affinity. You can even check at the application level also, but ALB is providing that option. Now, as far as integration is concerned, you can ALB can directly easily integrate with application web application firewall shield, which is basically doing DDoS protection. So DDoS protection is very important. So suppose there are a lot of hits which are happening, right? If there was no load balancer and if the instances are directly hit, obviously because of DDoS, it is very much possible that it might bring down the instances and it will keep on restarting. So that is the problem that we can avoid using the ALB when ALB is integrated with AWS Shield. Then you have the CloudWatch matrix. Basically, all the logs that are getting generated, you can send it to CloudWatch matrix. You can get alarms, etc. And that alarms, etc., can be used for various purposes. And then for the SSL, etc., and those kind of certificates, you have AWS Certificate Manager, which is easily integrated here. And then ALB also can be called via the Route 53, which is the DNS integration. And then we have the Global Accelerator, which is actually the Anycast IPs. So these are the direct integration that you can directly use with ALB, and it is very easy to get integrated with the ALB. Now, as far as logs are concerned, so ALB access logs, they can be directly delivered to S3. You can store the access logs to S3. And as I spoke about the target group, right? So target group, there are various target types that you can actually set up. So you can set up EC2 instances. You can send it to the IP address. Your target groups can basically have IP addresses, lambdas as well. Let's go to the AWS console. What I have done is basically these are my instances, admin instance and shop instance. Okay, these are basically, as you can see, this is my admin instance. Okay, here I am calling my admin instance, and it is giving me the response of private IP address of admin instance. And if I look here, this is my shop instance. This is my public IP address. And if I hit this, it is calling 10.0.0.5. Okay, so it is hitting this particular instance. Now, how it is hitting this instance? Because we are directly connected to this instance. But now, suppose I want a load balancer on top of this. So, how you do that? It's very simple. You first create the target group, which I spoke about. Okay, so now we have this target group, and this target group target type is instance. My protocol and port is everything is set up here, and I'll register the instance. So I have registered for admin group. My registered instance is admin instance, which I have set up. Okay. And similarly for shop group, this is my instance. Then I have set up the shop instance here. If I go to load balancer, so in the load balancer, if I go to the resource map, you can clearly see there is one listener which is listening on HTTP 8080. So if I am sending 8080 HTTP as my method and 80 as my HTTP as my protocol, 8080 as my port, then these are the rules that I have set up. So this is my rule number one. If the path is API slash admin, so this is going to hit my admin group. Okay, this is my first rule number one. Just keep this in mind. This is path based routing that I have done. As you can see, it is path pattern. Here, what I'm saying is, if it is API admin, go to this instance. If it is API shop, this is my second rule. Then it will go to shop group. And say suppose it is something else. By default, it is going to send a fixed response. Okay, so this is what my ALB is doing in the case of listeners and rules. Let's check this out. One more thing, like I told you, ALB will provide me a DNS name. So now for my both these instances, I can easily use ALB on top of this. So let me do that. If I do 8080, now first I am hitting the admin instance. Let's see. As you can see, it is hitting the admin instance. It is giving me the private IP address as 10.0.0.6. Okay. And now I'm not changing anything. I'm just changing the path to shop. Now it is hitting my second rule and I'm getting the shop instance IP address. And then suppose I send some random URL, then my default rule is executed. So this is how the listeners and the rules are working here. I have set up only one listener here, and here there are three different rules that I have set up in the listeners and the rules. Here you can see this is the rule that I have set up. If it is matching API admin star, forward to admin group, the target group that we created earlier. So it is passing on to that. So this was about the load balancer. This was the theory part about the load balancer. The hands-on part is in the other video. Thank you so much. Have a good day.